The first bits of question 10 are like only 1 mark. It's part 4 where there's 7 marks. So the first bit, it's that unfortunate sort of chatty maths. So method A is choosing a random sample of 24 appointments from the 288 appointments on that day. So what is a disadvantage? Well, a random sample is good. There are lots of advantages to it. A disadvantage is that you might have chosen a particular day, i.e. a school day, so you'll probably get a lot of old people or a lot of babies, so it may not be representative method A. So it may not be a good representative of all the patients at the clinic. So not many working adults, not many school-age children, basically the young and the old who aren't at work or aren't at school or college. Method B, choose one doctor's first and second appointments, choose another doctor's third and fourth. So a disadvantage of that, again, there's advantages to it, but a disadvantage to it may mean that a doctor's first and second appointment may not be typical. They may be working people, they just may not be typical. Again, it's unfortunately a bit of a vague question, but it's 1 mark for each. The next one, you can see that you're wanting to test whether or not patients take 10 minutes on average. To test this suspicion, you use method A and carries out a random sample of 24 appointments. Why do you think it's going to be a one-tail test? Well, probably because it's highly unlikely that they're going to take less than 10 minutes. They suspect that they're going to take more than 10 minutes. So your answer could be something like, researchers expect more than 10 minutes for an appointment, so greater than 10, not equal to 10, highly unlikely. Right, part 3. So you might want to have a quick refresh of page 402, where you've got your notes on testing, so significance testing. So I'm going to do this using 2 methods. I'm going to do the p-value, and then I'm going to see whether it lies in the critical region. So first of all, we're going to test, part 3, I've jumped too quickly. Part 3 is only 1 mark. Assuming that that mu equals 10, you're going to state the probability that the conclusion of the test will be that mu is not greater than 10. Well, that's just sort of testing about, do you know the meaning of a significance level? So basically, that literally means that that if your alternative hypothesis is mu greater than 10 at 1% level, probability of that happening is 1%. So the probe as being less than that will be 99% or 0.99. Right, question part 4 is where it all kicks off this, where all the marks are. So it says here the actual times, in the actual length of time in minutes that the patient spends their appointments may be assumed to have a normal distribution with standard deviation 3.4. So your null hypothesis, mu equals 10, your alternative hypothesis, mu is greater than 10. You are under the null hypothesis. Your mean, remember when we're looking at means, it's your variance over n, isn't it, for your sample means. So we assume that. Now we know that if we're looking at total length of time for the 24 appointments is 285 minutes, then X bar for those appointments is going to be 11.875. So under the null hypothesis, let's find the probability of X bar being greater than that, greater than or equal to it really. So using your normal distribution on your calculator, you're going to enter those values in. So, right, let's see what happens. That probability is tiny. So the probability of this happening under that null hypothesis is less than 1%. So you're going to reject the null hypothesis. Okay, so this has been seen. If this was under the null, it would be highly unlikely, so we reject the null in favour of the alternative. If we were going to do it using the critical region, So we're going to do it using the critical region. Again, we set up our X bar. We do our null and alternative hypothesis. We then find the value, we're testing at the 1% level. So the 1% level is the critical region. And if our value lies in there, we reject the null. So using the inverse normal, we find our probability. We find our value, which is 11.6. Now, if our X bar is greater than 11.6, it lies in the critical region, which it does, so we reject the null hypothesis. There it is, lying in the critical region. Right, and then the last part, in part 6, it was necessary to use the fact that the sample mean is normally distributed. Give a reason why you know that this is true in this case. Well, because the times were normally distributed, you know the sample means were. All right, question 11. Question 11, so correlations, you know that those points look like they're really close to a straight line, so it's 0.913. So basically, you're only taking this from one area, so that could be a reason why the statement is incorrect, not random. Part 3, both of these depend on the size of the population. And part 4, this is the point. So that would be the point that you would label A. Part 5, you're looking at, one reason might be more local jobs, means more people walk to work. And part 6, got fewer walking to work, and B moved closer. That's one more question. Right, people moved, right, or closed down. Right, at first glance, I thought question 12 looked quite hard, but then when I worked out a sample space diagram, it's reasonably straightforward to work these values out. So when x is less than or equal to 3, so obviously 1, 2, or 3, you work out the values of s using x plus 2y. If x is greater than 3, you work out the values of s using x plus y. And then actually, I kind of liked this question. Well, first I thought it was horrible, but then it turned out to be quite easy. Right, part 1, draw up a sample space diagram showing all the possibilities and corresponding values of s. B, circle the 4 cells where s equals 10, so you could see I've done that. Part 2, explain the mistake in the following calculations. Well, these outcomes aren't equally likely because the probability, although on the fair dice, each one has a probability of a 1/6, on the biased dice, they have different probabilities. Part 3, the probability of x equaling 10. So you would think of all the ways that could happen. So you get 4 on y and 2 on x. You get 6 on y and 4 on x. You get 5 on y and 5 on x. You get 4 on y and 6 on x. So you work out the probabilities, getting the y probabilities from your table. And of course, always add, so it's 0.065. And then lastly, part 4, you've got a conditional probability. So the probability of getting having a 4 on one of the dice, given that s equals 10. So using your formula for conditional probability. So these are the probabilities of the ways of getting 4 on one dice and s equaling 10 divided by the probability s equals 10. So giving you that probability. And then for 5, just look at the table in the rows x equals 1 or x equals 2. And the value that's not in there is n equals 15.